Good morning, students. Students, in our previous lecture, we discussed with you the classification of matter. And I told you it can be done either by the physical classification or by the chemical classification. Now, when we were discussing the chemical classification of matter, we came across the three words: elements, compounds, and mixture. I gave you the definition of a mixture. I gave you the definition of an element, and I also gave you the definition of a compound. What was compound? Compound is a pure substance which contains two or more than two elements united chemically. As for example, water. Now, student, if we want to illustrate this work, that is the compounds, then we have to study certain laws of chemical combination. These laws of chemical combination are law of conservation of mass, law of constant proportion, or we may call it as a definite proportion, law of multiple proportion, then the law of reciprocal proportion, and then we have a law of gaseous volume. Am I clear? First of all, students, we will discuss with you the law of conservation of mass. Now, this law of conservation of mass was given by the scientist Lavoisier. Who gave this law? It was given by the scientist Lavoisier. And when was it given? In the year 1774. Am I clear? Now, what does this law says? You have studied this in the lower class also. According to this law, in any chemical change, the total mass of the system remains constant. Am I clear? So, in all the chemical changes, the total mass of the system or the chemical change will remain constant. Am I clear, student? So, according to this law, in any chemical change, the total mass of the system remains constant. In any chemical change, the total mass in any chemical change, the total mass of the system remains constant. The total mass of the system remains constant. Total mass of the system remains constant. Am I clear? So, during any chemical change, the total mass of the system remains constant. So, I must say over here, the total mass of reactant, this will be equal to the total mass of the product. Total mass of the reactant is equal to the total mass of products. Am I clear, student? So, during any chemical change, the total mass of the reactant will be equal to the total mass of a product. Just see over here. If we write down this way, silver nitrate, when react with a sodium chloride, what will happen? It will result in the formation of silver chloride and sodium nitrate will be given out. What does the law of conservation of mass says? The total mass of a reactant will be equal to the total mass of the product. Now, suppose if I say the mass of reactant is a 14 gram and over here 12 gram of AgCl is formed. So what will be the mass of a sodium nitrate? We have to determine this. Let it will be x gram. Am I clear? So which law will I apply? The total mass of the reactant will be equal to the total mass of the product. So over here this will be 14 will be equal to 12 plus x. So x over here will be equal to 2 gram. Now if this x comes to be 2 gram, 12 plus 2 will be 14. So total mass of the reactant will be equal to the total mass of our product. Am I clear, student? Which law is this? It is a law of a conservation of a mass. So what does the law says? According to this law, during any chemical change, the total mass of a system remains constant. The first law is clear. Now the second law is the law of a constant proportion, or we may call it as a law of a definite proportion. So second law. Second law is the law of constant proportion. Law of constant proportion. Which can also be called as law of a definite proportion. So law of constant proportion or the law of definite proportion. Now what does this law of constant proportion or a definite proportion explains? Listen to me very carefully, student. According to this law, a chemical compound always contain the same element in same proportion by mass, no matter from which source it has been obtained. I mean to say, irrespective of the source from which the compound is obtained, it will always contain the same element in same proportion by mass. Am I clear? So what does the law says? First of all, who gave this law? This law was given by the scientist Proust, and when? In the year 1799. So the law was given by the scientist Proust in the year 1799. Am I clear? According to this law, chemical compound always contain the same element. Chemical compound always contains the same element. Chemical compound always contain the same element. Always contain the same element in same proportion by mass, combining same proportion by mass, combining same proportion by mass, combined in the same proportion by mass, irrespective from the source, irrespective from the source from which it is obtained, irrespective from the source from which it is obtained. It is obtained. Or we may simply write down, irrespective from the source it is obtained. Am I clear? What does the law says that? A chemical compound always contain the same element combined in the same proportion by mass, no matter from which source it has been obtained. As for example, if I say water, What is the formula for water, students? This will be H2O. All of us know the formula of water. Now we know water can be a lake water, it can be a sea water, it can be a rain water, it can be a tap water, anything. Am I clear? But from whatever source, either lake, river, sea, oceans, wherever, the formula for water will remain H2O. It will contain which two elements? Hydrogen and oxygen. It will always contain hydrogen and oxygen. How many atoms of hydrogen will be there? 2. What is the mass of those 2 atoms? 2. How many atoms of oxygen are here? 1. What will be its mass? 16. Atomic mass of oxygen is 16. So what will be the ratio over here? It will be 1:8. So what does the law says? A chemical compound, let me take here water, always contain the same element. What does the water contain? Hydrogen and oxygen. Combined always in the same proportion by mass. Their mass ratio will always be 1:8, irrespective of the source from which it has been obtained. Am I getting clear, student? Which law is this? This is a law of a constant proportion. Now suppose we take carbon dioxide. We take carbon dioxide. Carbon dioxide is a gas. By what various ways we can obtain the carbon dioxide? Carbon dioxide can be obtained when carbon combined with oxygen. It may result in the formation of a carbon dioxide. This can be one way by which carbon dioxide can be obtained. The other way can be if you take carbon monoxide gas. Carbon monoxide gas when combines with oxygen gas, it may again result in the formation of carbon dioxide. Am I clear or not? Suppose we carry out this reaction. Suppose the calcium carbonate. Calcium carbonate react with HCl. What will happen? It will result in the formation of calcium chloride plus water plus a gas will be given out, and the name of a gas is carbon dioxide. So what does the law says? A chemical compound, carbon dioxide is a compound, always contain the same element. You may see it contains carbon and it contains oxygen. Combined in same proportion by mass. What will be the mass of carbon over here? 12. What will be the mass of oxygen over here? 32. Irrespective of the source from which it is obtained, you may see here it may be obtained by combination of carbon and oxygen, by carbon monoxide and oxygen, or by the reaction of calcium carbonate and HCl. From whatever way you obtain the carbon dioxide, the formula of carbon dioxide will remain as CO2. It will contain always and always carbon and oxygen combined in the ratio by mass of 12:32, which will come to be equal to 3:8. So which law is illustrated? It is a law of constant proportion. Who presented this law? It is presented by the scientist Proust. When? In the year 1799. Now, recapitulate the definition of a compound I discussed with you in the previous lecture. What was a compound? Compound is a pure substance which contains two or more than two elements united chemically in a definite proportion by mass. This was the definition. Here carbon dioxide is a pure substance containing two or more than two elements united chemically in a definite proportion by mass. Have I illustrated the definition of a compound or not? Yes. Why are we studying the law of chemical combination? In some way or other, I will be illustrating the points I have discussed or will be discussing with you in the chemistry. One is the law of conservation of a mass. We will be using this concept again and again, and that will be giving total mass of a reactant will be equal to total mass of a product. And by the law of constant proportion, I have been able to illustrate to you the definition of a compound, which says that compound is a pure substance containing two or more than two elements united chemically in a definite proportion by mass. What does the law says? Law says a compound may be obtained from any source, but it will contain the same element in the same proportion by mass. So I hope, student, you must have been understanding what I want to teach to you. Is it clear? So the two laws we have done, and this is the law of conservation of a mass and the law of a constant proportion. Is it clear to you? Now, the third law, student, is the law of multiple proportion. Third law is law of multiple proportion. Law of multiple proportion. This law of multiple proportion was given by the scientist Dalton. And when was it given? It was given in the year 1808. Now, what does the law say? Listen very carefully, student. According to this law, I repeat, according to this law, if two different elements combines to form two or more than two compounds, then the different mass of one element which combines with the fixed mass of the other element, the different mass of one element which combines with the fixed mass of other elements bears a simple ratio to one another. Am I clear? I don't think am I. Just see the example here. If I say there are two elements, hydrogen and oxygen, and if these two elements combines to form two or more than two different compounds, let me say two compounds. So hydrogen and oxygen combines to form water. This is clear? They may also combine to form hydrogen peroxide. You know these two compounds? When two different elements combines to form two or more than two different compounds, then different mass of one element. Out of these two elements, mass of one will be different. What is the mass of oxygen over here? 16. What will be the mass of oxygen? 2 into 16. This will be 32. Am I clear? Then different mass of one element, that is oxygen, which combines with a fixed mass of other element. If you look over here, the mass of hydrogen will be 2. Here again the mass of hydrogen will be 2. Then different mass of one element which combines with the fixed mass of other element bears a simple ratio to one another. What is the mass of hydrogen? 2. What is the mass of hydrogen? 2. It is fixed. What is the mass of oxygen? 16. What is the mass of oxygen? 32. So, what will be the ratio of oxygen? This will be 16 ratio 32. Am I clear? So, what will be the answer for coming? 1 ratio 2. Is it not the simple ratio or a simple multiple ratio? Yes. So, the law is illustrated. So, what does the law say? I am writing the statement of the law. According to this law, when two different elements combines to form two or more different compounds, then different mass of one element different mass of one element which combines with fixed mass of other element. Different mass of one element which combines with fixed mass of other element. Am I getting clear now? Bears simple ratio to one another. Bears a simple ratio. I mean to say simple ratio or a multiple ratio. Bears a simple ratio. Is it clear, student? So what does the law says? When two different elements combines to form two or more different compounds, then the different mass of one element which combines with the fixed mass of other element bears a simple ratio. As over here, the mass of oxygen was different. It was combining with the fixed mass of hydrogen, so they were in the simple ratio to one another. Is it clear? You may see another example. If you take carbon monoxide and carbon dioxide. Carbon monoxide and carbon dioxide. What is the mass of carbon here? 12. What is the mass of oxygen here? 16. What is the mass of carbon here? 12. What is the mass of oxygen here? 32. Is the mass of carbon fixed or not? Yes. Which is the other element? Oxygen. What is the mass ratio between these two? This will be 16 ratio 32, which will come to be a simple ratio, which is 1:2. Am I getting clear? So how many laws have we discussed today, student? 3 laws. First was law of conservation of mass, law of law of constant proportion, and third was a law of a multiple proportion. Am I clear, student? Law of conservation of mass, law of constant proportion, and the law of a multiple proportion over here. Law of a multiple proportion. Now, the 2 laws which are left are the law of reciprocal proportion and the Gay-Lussac's law of a combining volume. I repeat, the law of reciprocal proportion and the Gay-Lussac's law of a combining volume, which we will be discussing in our next lecture. Till then, thank you.